Okay, today's lesson is on Chapter 1, Lesson 3, Exponents. You all are totally familiar with exponents. You've worked with them for actually several years now. So, I am not going to go over a whole lot here in detail, okay? But I do want you to write some things down. So in your notebook, first of all, make sure you have today's date at the top of the page. Make sure you have 1.3, Chapter 1, Lesson 3 written somewhere, and the objective. I also want you to go ahead and write this vocabulary page because this is the basis for the whole lesson, okay? So vocabulary, a power has two parts. The two parts are a base and an exponent. There's a picture here to show you. You can see in purple the word base with an arrow showing you which part is the base, and the word exponent with an arrow showing you which part is the exponent. Okay? And then on the bottom underneath that you have an example. So a to the power of m means a times a times a, however many times m says. Okay? And these are called factors because you're multiplying. Okay, so make sure you have all this down. If you need to pause, go ahead and pause. And I'm going to add just a little bit there at the bottom for you. As you can see, exponents are repeated multiplication. What I want you to make a relationship with is multiplication, what it normally is. So multiplication is repeated addition. So by repeated addition, sorry, we changed colors. Hopefully you can't see that. Okay, so by repeated addition, what I mean is, let's say I have 3 times 4. So 3 times 4, well, what is multiplication? It's the same thing as exponents now here. It's repeated addition. So exponents, repeated multiplication. Multiplication, repeated addition. So let's look at what I mean here. When I say 3 times 4, what I mean is we're going to add the number 3 4 times. So what this means is 3 plus 3 plus 3 plus 3, right? I'm sure that's how you all learned about multiplication, was repeated addition. Well, exponents are the same thing. Repeated multiplication, though, not addition, repeated multiplication, okay? So make sure you all have this down. Let's go to the next screen. Okay, now, this is what you do not have to write down. Don't write this down, okay? Example 1, reading a power. A power, again, is the word we use when we're talking about exponents. So we don't say like 3 to the 5th exponent. We say 3 to the 5th power. Okay? It's just a word we use for that. So we're going to state a verbal phrase. So when verbal means you're talking. So a verbal phrase for the power, and then we're going to write the power using repeated, what is it? Multiplication, right? Not addition. So letter A, 6 to the power of 2. Or 6 to the 2nd power. Verbally, 6 to the 2nd power. And if you remember from last year, you can also call the 2nd power squared, the word squared, or 6 squared. And as repeated multiplication, what does that look like? Well, how many times are we multiplying the 6, right? So we're going to focus on the exponent here. Okay. And this tells us how many times we're multiplying that. How many times are we multiplying 6? 2 times, right? Okay, so then the repeated multiplication looks like 6 times 6, right? Okay, again, you didn't have to write any of that down. We're just going over it. Example B, again, same thing. Verbally, how do we say this? We say 10 to the 3rd power. Right? Or, as you learned last year, when it's to the power of 3, we also call that cubed. So, 10 to the 3rd power or 10 cubed. And then how do we write that as repeated multiplication? We write 10 times 10 times 10. Again, you don't have to write any of this down. Okay? Next screen. C. One more example. X to the 4th power. Verbal, x x to the fourth power. We don't have any special words to the fourth power. We only have those special words for to the second power, which is squared, or to the third power, which is cubed. After that, you just use your ordinal numbers, fourth, fifth, sixth, seventh, whatever they are, okay? And the word power. Multiplication, now what does that look like? We're multiplying x 4 times. X times x times x times x, okay? Now, how do we evaluate a power? Remember, the word evaluating means give the value of. So how do we give a value to those powers now? So we want to evaluate x to the fourth power when x is 5. So we, first of all, remember the word. This is a very good word for you to remember, substitute. Substitute, right? When you substitute, you put something in the place of something else. This is telling us that x is 5. So we have to put 5 in the place of x. So first thing you're going to do is substitute. Again, you don't need to write this down. We're just watching. The repeated multiplication of that then is going to be 5 times 5 times 5 times 5. Okay? How do we do that? One of the easier ways, because of the commutative property, remember, it doesn't matter what order you multiply in. So I don't have to necessarily say 5 times 5 is 25. 25 times 5 is 125, and 125 times 5 is 625. You could do it that way, but you don't have to. So here's the other way you could do it. You could say 5 times 5 is 25. Bring this down, times, and these two, 25. 25 times 25. Okay? So if you're saying 25 times 25, and then you multiply those together, you're going to get 625. Now we have a value for 5 to the fourth power. 5 to the fourth power is 625. Next slide. How can we use this with area? Well, that's really what you're doing, especially when you find the area of a square. All the sides are equal, right? And with area, we multiply length times width. Well, they're both the same number, 90, so we can make 90 the base, right? And then the exponent would be squared, multiplying 90 times 90 for area. This one, I do want you to write down because I do think we need some review work in area. Okay, so I want you to write example 3, finding the area of a square. Okay, we're just going to go ahead and highlight what you're going to write there. You're going to write this, finding the area of a square. Sorry, I got a little crooked there. Okay. And I want you to write the word problem. A baseball diamond is being fertilized. Each bag of fertilizer covers 1,200 square feet of grass. About how many bags of fertilizer are needed? So if we're talking about covering the entire area of something, then we need to figure out how much area there is. So we need to find out. I'll highlight it for you. First of all, don't forget you're writing all of this down. I want you writing all of it, okay? The whole word problem. Draw the picture as best as you can. Draw this picture. What we're finding is the area, so I'm going to highlight that for you too. What is the area? Where is the area? The area is all of this in here. All of this is the area. Okay? And this is what we need to figure. How much fertilizer is it going to take to cover all of this? Right? So, a couple things here. We have to find out how much fertilizer it's going to take to cover it. And then we're also going to have to figure out how many bags will we need to buy. Okay? So first let's find the area of this. The area, 90 squared, or 90 times 90. Because the area of a squared is one side raised to the second power. Multiplying the number by itself. 90 times 90. So repeated multiplication, 90 times 90 is 8,100 feet squared. 8,100 feet. Now how many bags of that 1,200 square feet bag do I need to cover 8,100 square feet? So for instance, if I have one bag, that covers 1,200. If I have two bags, that covers 2,400. If I have three bags, that covers 3,600. And we move on, counting by 12. Okay? So let's look at the next page and see what we have. Okay? So, was that the final answer? No, because it doesn't tell us how many bags we need. The question is to find the number of bags, not the area. Once you find 8,100 feet squared, that's the area. So this is your critical thinking here. What do I still need to do? You still need to divide 8,100 by 1,200. See how many times 1,200 goes into 8,100 to see what you need, how many bags. Okay? You do not have to write this page down. This is just us thinking. Don't write any of this down. Okay? So, I'm sorry. There we go. So 8,100 divided by 1,200 is a decimal. It's 6 and 75/100ths. How many bags of fertilizer do you think we need then? 6 or 7? Because I can tell you right now, when you go to Home Depot and you tell them you need fertilizer, they're going to ask you how many bags. You can't tell them 6 and 75/100ths. They're not going to break a bag open for you, empty out 2,500ths of the fertilizer, throw it in the trash, and give you the rest of it. Not going to happen. So how many bags do you need? Hopefully you said 7. That's right, you would need 7 bags of fertilizer. Okay? Now I want you to write your guide to practice down. Okay? So let's go back to the vocabulary. 2 parts. Okay, you may have to pause the video to write it down. Go ahead and pause wherever you need to pause. Okay? A power has 2 parts. What do we have? Hopefully you went back to the first slide. You rewound the video here to look at what those 2 parts are in case you forgot. Base and exponent. Right? Next, I want you to write a verbal phrase for the power. I'm not going to say it because that is the verbal phrase that you would have to write. Then I'd be giving you the answer. So again, you can go back, rewind this video, and see if you can find the answer here. Verbal phrase for the power for this one. I'm not going to say it. I almost said it. You guys, you always trick me. All right. Give you a minute to think about that. Okay, so we have 3 to what power? 4th power. That's what you should have written. Next, rewrite the power as repeated multiplication. Then, I also want you now, we're going to add on here, I want you to evaluate it. Give me the value of that. So repeated multiplication, I have 4 squared, or 4 raised to the 2nd power. 4 to the 2nd power. How many times do I multiply that 4? 2 times, and my answer then, 4 times 4, is 16. Again, 7 raised to the 2nd power, or 7 squared, is 7 times 7, or 49. Right? So on this one, the instructions say to rewrite the power as repeated multiplication. Then give the value of that. Okay? So 3 to the 4th power as repeated multiplication means you're multiplying 3. Think about it. How many times are you going to multiply 3? Okay, your answer should have been 4 times you're going to multiply 3. So that means 3 times 3 times 3 times 3. When you multiply that, and there's different ways to do it, so let me show you. You can do 3 times 3, which is 9. Bring down the multiplication. And 3 times 3 again, which is 9. And then multiply these 2 numbers for 81. I want you to get used to thinking creatively. How can I do this a little bit different? Do I have to say 3 times 3 is 9? 9 times 3 is 27. 27 times 3. Obviously, that's not a math fact. You don't have the answer in your head. You're going to have to write it out. Is there an easier way to do this? Yes. Multiply 2 3s, then multiply the other 2 3s, then multiply the 2 9s. Those are all math facts. So you have to think more creatively, do more critical thinking to figure out how you can do problems in different ways. Number 6, 2 to the third power. Again, rewrite it as repeated multiplication and write the value of it. So 2 to the third power means 2 times 2 times 2. Your answer is 8. Okay? Listen, when I'm doing this guided practice, you need to pause this video when you see the problem. Try to do it on your own. Then play the video. I'll pull the arrow over and you can see if you got it right or not. Okay? So let's do the next one like that. Okay? So this is a word problem. Try it before I pull the arrow over. You are designing a garden. You want to have a square plot. That means, remember, a square. What do you already know about a square? All the sides are equal. So make sure when you're reading these that these vocabulary terms, that you understand them. Square, all sides equal. With each side measuring 14 feet. For me, a good way to do this is to make a drawing. So draw that square. Label the sides of the square with their measurement, which is 14 feet on each side. Now, that word square has multiple meanings in math though, doesn't it? It could also be to the second power. That also means squared. Finding the area also means squared. Okay? So, the area of this is going to be 14 squared. So we have the square, 14s on each side. I know to find the area, which means everything in here, all of it. I'm going to find 14 squared. Area equals the side squared, so that's 14 squared. To do this, I'm going to multiply 14 times 14. Right? So you get 16, 5, 0, cross it out, 4, 1, add. So area should equal 196 feet squared. And we get 14 squared equals 14 times 14 equals 196 feet squared. What would the area be if each side measured 28 feet instead? Well, you already have the strategy, so there's really no need to draw the square again. So this time you're just going to write area equals 28 squared. Area equals the side squared. What is the side? It's 28. 28 squared. What does this square mean? It means to multiply 2 times. 28 times 28. So we multiply 64, 22, 0, 16, 5, and add. So our answer is 784 feet squared. (28 times 28, 784 feet squared. We got it. And that's it for today. Now you're going to get better at watching these just like I'm going to get better at making these. Make sure please that you pause in all the places to make sure you're trying these on your own and then watching how to do them. Okay? Thank you, and be ready in class tomorrow to show me those notes and maybe even take a short quiz.